Can you hear us?
Yes, yes.
Добрий день.
Добрый день, good morning, dear friends.
So it is a very, very special occasion for us that one day before of the official celebration of your anniversary, 120 anniversary, we are gathering and we want to discuss about the perspectives, what is going on in the field of industry, in the digitalization, in aspects related to advanced manufacturing, and the way in which the universities, of course, could be involved in all this process. So sometimes there is a word from old people. They say, look to somebody on the way in which he is celebrating, and you will understand the future of that somebody. So your university is celebrating the 120th anniversary with such a conference. We have outstanding speakers. There are many, let's say, universities and institutions that have been interested on this topic. And with all this said, I would like to invite Rector Belikov to say a few words for the welcome in the beginning. Rector Belikov, you have the floor. Rector Belikov, can you hear us? Rector Belikov, we are not following you. So, yeah, it looks like we have some problems with the connection. So, besides of Rector Belikov, we have also some. Hello. There is something with your microphone. Yeah. It is blocked. I cannot open it from here. So, with your permission, I would like to go further in our program, and I would like to invite Professor Volodymyr Onyshchenko, the rector of National University Yuri Kondratyuk of Poltava Polytechnic from Ukraine. Professor Onyshchenko, can you hear us?
Good morning, dear colleagues. I am glad to see you, dear Secretary General Professor Eden Mamut, dear Rector Professor Sergei Belikov, Prorector Oleg Matveikiv. We are very pleased that National University Yuri Kondratyuk Poltava Polytechnic is a partner and co-organizer on so actual topic, perspectives in industry, digitalization and advanced manufacturing in the Black Sea region. Unfortunately, the whole world is going via difficult times. The pandemic has made a big difference in our normal lives, but it doesn't mean that we should reduce our plans for strategic partnership and collaboration. We have to learn how to live and work in new conditions and together overcome today's challenges. And it's digital technology that will help us in it. At Poltava Polytechnic, much attention is paid to digitalization and digitization. Together with world leaders, such companies as Siemens, Autodesk, Schlumberger, we successfully implement digital technologies in the educational and scientific process. Taking the opportunity, I congratulate my colleague and my friend, Rector Professor Sergei Belikov, on the anniversary, the 120th anniversary of Zaporizhia Polytechnic. I wish success to our conference and good health to all of you. Thank you very much.
Thank you very much, Rector Onishenko. Very nice words, and I hope that the collaboration that we have under the frame of the Black Sea Universities Network will continue. So now I would like to invite Rector Oleg Madvikiv from Lvov Polytechnic National University. Professor Madvikiv, please, you have the floor.
Thank you very much. Dear ladies and gentlemen, dear participants of the conference. First of all, I taking into account that this conference is devoted to the 120th anniversary of the foundation of the Zaporizhia Polytechnic National University. I would like, on behalf of the rector, our rector, Professor Bobolo, and our management team of our university, to congratulate the rector of Zaporizhia Polytechnic National University, Professor Sergei Belikov, and the whole academic community with this significant day. I know that the university has passed a long way on its growth and its development. I have read that from small technical school that trained mechanical technicians to now modern national technical university. So this is an example of real dedicated work of the talented and professional team that management and that manage all difficulties and troubles during its history. So please accept our sincere congratulations and wishes of great inspiration, prosperity on your further way to high goals. So I know that our universities have strong and lasting scientific, cultural, and personal relations. So I hope that they will continue. And I wish Mr. Rector, all employers, as well as their families, strong health in our difficult coronavirus time. And well, all happiness and optimism for every day. So returning back to our conference, I'm really happy that Lviv Polytechnic is a co-organizer of this conference. This is a very important topic, and it's a great honor for me and pleasure to participate in this opening ceremony and to welcome the conference participants. So we all know that industry digitalization is and its branches or subsequent branches like Industry 4.0, Industrial Internet of Things, Big Data, Artificial Intelligence, and others. So this is a future of mankind, and we have a lot of examples of this thesis. So we all know that Zaporizhzhia is a great and powerful industrial region in Ukraine. So it's really naturally that the conference of industry digitalization was organized and take place in your university. Analyzing the development of new concept on industrial digitalization, as well as preparing and implementation new educational programs for digital transformation. We know that these are important functions of each university, each modern university. So I wish all participants real fruitful work, new creative ideas, success in establishing strong relations for further scientific, for further research grants, and so on. Also, I would like to invite you to visit our Lviv Polytechnic National University. We also had a lot of interesting achievements, educational and research achievements. So I hope that this coronavirus epidemic situation will finish sometimes, and this conference we will be able to organize in our university as well. So I'm sure that together we can do more and we will be more successful. Thank you very much and good luck.
Thank you very much, Rector Matvikiv. Very nice words. I'm sure that this topic of digitalization and advanced manufacturing could be a very fruitful area for continuing these kind of meetings and conferences and even joint projects, because also the Lviv or Lvov area is an area where now there are new developments, new investments, and it is an area that is moving very fast. So from that perspective, I think it will be a nice opportunity to have an activity maybe in the future together. So let us once again thank you very much. So now we are coming back to Professor Belikov. Is there any chance to hear you, Professor Belikov? So we are waiting for this. Now it is a very great pleasure for me to have here with us our very close collaborator, Dr. Steffi Friedrichs. Steffi, are you online?
Yes, I am. Good morning to everybody.
Hello, Steffi. So once again, thank you very much that you accepted to join us in such a very important gathering here on the other side of Europe. So I know that you are based in Brussels, and you are developing a very intensive cooperation with the industry there, and you are developing also a very intensive activity under the frame of nano safety. So from that perspective, if you would like to say a few words regarding, let's say, the current trends in aspects like resilience and safety, and the aspects of course, safety by design concepts and other concepts that are now fundamental elements for the next phase of the industrial development. Dr. Friedrichs, you have the floor.
Of course, good morning. Many thanks for inviting me to be here, and good morning to everybody. And it is a great honor to be able to participate in this opening ceremony. And I'm sorry I can't, like everybody else on the phone before, name everybody else and say specific hellos to everybody, but it is a great honor to be here, let me assure you that. I do recognize some of you. Most of you don't have your cameras on, but I do recognize some of you from my very first trip to Constantia last year in June, I think it was, where we had a really good meeting. And again, my warmest memories of that meeting. What we are trying to do from this side, from Brussels, where we are trying to establish many more connections to the network, is we're trying to bring industry and the regulatory bodies together a little bit more. And we're doing that under the context of Safe by Design. Let me just give you a very brief introduction to what Safe by Design is and leave the thought with you for the rest of your meeting today so that you can consider that as a tool that you may want to use. Safe by Design it's not a pre-made thing. It is essentially something that is up to everybody's interpretation, but it has a few principles that are different from how the development and the innovation of innovations is done today. And that is, we are starting from a very early point to have a dialogue between the regulatory bodies, so like risk assessment bodies, and the industries. So the current regime of getting innovation to the market is quite often seen as something that it comes at the end. You innovate, you have your product, and then you try to get it to market, and you have to talk to the regulator about any testing you need to do. Safe by Design does that differently, although it is a little bit exaggerated to really name the current innovation only having safety testing at the end. But in Safe by Design, we want to use a collaboration throughout the entire innovation value chain. And we want to make sure that industry speaks very early to regulatory bodies and to academia that is working with preparedness, with regulatory preparedness, in order to make sure that everybody learns, so that the regulatory bodies know what they need to ask about a new product, and so that the industry from the very start can have a corridor in which it can innovate freely. And this sort of dialogue and sharing of responsibility is something that has done very, very well in the development of nanomaterials, specifically under the OECD, where collaboration is a key. And I do believe that our current situation with regard to everybody being in the same boat, fighting a pandemic, lines between industry and regulatory bodies and academia fully in line with that by receiving funding for some of their good research as well along the ways. So I would like you to leave you with these thoughts, and maybe that is something that you can now use in your elaborations for the day and come up with something that we can collaborate on at the end. Thank you.
Thank you very much, Dr. Friedrichs. What we know is that you already have sympathy for the Black Sea region and for the partners from this area. And I am sure that most of the universities that are represented here and some of the industries, they are potential partners of let's say, first of all, your consultancy group, Acumenist, but also besides that, the consortia in which you are active, different associations, and so on. So we consider you as our pillar partner in Brussels, and we are looking forward for different new project proposals and so on. So once again, thank you for your time. I know that you are very busy and you had this, let's say, kindness to join us. Thank you very much. So now we are coming back to Professor Belico. And
okay. Try to be with you. Okay, once again, I am saying that I am glad to welcome all participants on this occasion devoted to 120th anniversary of our National University Zaporizhia Polytechnic. Unfortunately, it is online, unfortunately, because I think that Professor Eden Mamut remembers that 5 years ago he visited Zaporozhye on celebration of 115th anniversary. And it was much more enthusiastic to see you eye by eye. Still, really, it's a great event. I am more than sure that the organizational committee will decide to make celebration like an Olympic Games 2020 in 2021. That's why I hope that in spring or summer we'll be able to invite guests from all over the world, from all Ukrainian universities for this celebration. I am really thankful to our industrial partners. We invited the representatives of Motor Sich, and as Professor Eden remembers his visit to Motor Sich and Museum of Techniques by Professor Boguslayev. That's why maybe I propose to hear the presentation of our partners from Motor Sich, okay?
Thank you very much. So Motor Sich is a worldwide known company. You know very well that a few months ago it was a strong debate between different large powers all around the world regarding the way in which Motor Sich has continued different types of activities. So we are very interested on this presentation. Thank you very much, Professor Berry.
Yeah, and our partners are with us, so now they'll join with their presentation, okay? Так, вы как сюда?
Пусть садится, да. Сейчас я сделаю громче.
Колонки подцепить можно.
Сюда это.
Спартак, тебе микрофон здесь?
Микрофон сюда.
Попробуйте презентацию, новая демо есть. Или отсюда запустите.
Ну, как вы скажете.
Здесь, не знаю, как они это сделают.
Попробуем еще раз. Давай-ка, вставляй презентацию. Сейчас. Так, какие презентации у вас?
Спартак, покажи презентацию.
Конференция 20 ЦНТУ? А в чем сделано? Ага, кого берем?
Так, вот это.
Вот эту?
Да.
Так, на рабочий стол. Так, на рабочий стол.
Почему у вас на стол? Ну, такое развлечение.
Так, на рабочий стол ММ5. Пускай будет, давайте попробуем запустим презентацию. Если она запустится сегодня. Сегодня что-то день несчастливый на презентации. Так, давайте-ка мы ее откроем. Мы отсюда ее откроем. Так, presentation. Так, открываем полностью. Вот она. Будем туда клацать вниз. Пока мы переходим на... Сейчас, секундочку. Возьмет ли она его или нет, это вопрос. Попробуем взять скрин. Share. Не хочет. Display shared content. Ну а где бы нам контент-то выбрать? Так, разрешение. Использовать микрофон, доступ к экрану. Временно закрыт. Открываем. Сейчас я открываю. Уже не надо. Так, presentation Motor Sich. Разрешаю. Есть. Значит, теперь она там у них. Можем потихонечку клацать. Так, сейчас я проверю еще раз. Вот она и есть. Так, спросите, презентацию они видят?
Can you see right now our presentation?
Yes, we see.
Да, видим.
Okay, perfect.
Окей, поехали.
Let's start.
Добрый день.
Because we lost many minutes, try to make it condensed. Thank you very much.
Окей, мы потеряли немного времени, поэтому он просит немножко...
Да, я очень коротко. Добрый день. Я хочу поприветствовать от лица руководства Моторсич.
First of all, on behalf of our authorities, we would like to greet all of the participants of the conference.
Да, президента нашего компании Богуслаева Вячеслава Александровича.
Also, on behalf of our president Vyacheslav Boguslayev.
Я немножко расскажу о нашем предприятии.
And right now we are going to make a short presentation of our company.
Предприятие Моторсич имеет очень давнюю историю, уже более 110 лет.
Motorsic Stock Company has a long and rich history.
Президент нашей компании Вячеслав Александрович Богуслаев.
It's our president of our company, Vyacheslav Boguslayev.
На предприятии работает вместе с филиалами более 20 тысяч человек.
The staff of our company consists of more than 20,000 people, including subsidiaries.
Предприятие занимается производством газотурбинных двигателей для самолетов и вертолетов.
And the main activities are production of aero engines, both for airplanes and helicopters.
Здесь вы видите вот первый двигатель, который был выпущен в 1916 году.
Here you can see
поршневой.
the first piston engine, which was produced in 1906.
Давайте дальше. Это вот здесь представлена линейка наших двигателей, которые мы делали за вот период.
Next is the lineup of our products, aero engines also.
Компания Моторсич также выпускает двигатель для самого большого грузового самолета, как Руслан и Мрия.
It's also the largest cargo airplane, Ruslan and Mria, for which are powered by our aero engine.
Очень большая линейка, мы производим вертолетные двигатели.
Also, quite an extensive production line represents helicopter engines.
Все вертолеты, созданные КБ Миля, Камова, летают на двигателях производства Моторсич.
All million Kamov's rotorcraft are powered by our aero engines.
Наше предприятие сертифицировано по всем авиационным правилам, включая и европейские.
Our company has been certified according to international regulations.
Это позволяет нам летать. Наши двигатели летают в более чем 118 странах мира.
Therefore, our engines are operated in more than 118 countries.
Я немножко расскажу о наших технологиях.
We are going to make a quite short presentation about our technologies.
То есть мы обладаем замкнутым производством цикла производства двигателей.
We have a closed loop in-house production.
Здесь только некоторые технологии. Это
some technologies here represented.
Это освоили высокоскоростное фрезерование.
So we have mastered high-speed milling
дисков вентилятора.
High-speed milling of fan blisks.
Это дальше. Также мы сами купили высокотехнологичное оборудование, горячий изотерический пресс, который позволяет нам делать гранульные диски и турбины.
Recently, our company has acquired photoisostatic press, which allows us to produce discs through powder metallurgy process.
У нас единственная технология в мире производства титановых отливок без альфированного слоя в углеродной форме.
We possess unique technologies which allows to produce titanium castings free of alpha gas saturated layer.
Позволяет получать отливки диаметром до 1200 миллиметров.
With castings can be produced with the overall size of around 1 meter.
Дальше. Также вот уникальная технология производства монокристальных лопаток.
Also, we have mastered directional casting process for producing airfoil parts.
У нас 9 установок для вертикально-направленной кристаллизации.
Our facilities consist of 9 machines for directional casting.
Своими силами сделали автоматизацию этих установок.
Почали ж розбиратися в цій історії з цими ноутбуками. Виявляється, що нам не ноутбуки по великому рахунку потрібні, а нам всім потрібні нормальні комп'ютери. Бо нормальний процесор, це ноутбуки, це шалені гроші. Навіщо нам ці 100 тисяч і тому подібне. Тому згадали.
So unfortunately, it looks like we lost again the connection with the colleagues in Zaporozhye. So yeah. Hello, can you hear us? Because we lost you. We cannot hear you. Hello. Hello. So the colleagues from Zaporozhye, can you hear us? Hello. Hello. So unfortunately, we lost such a very interesting presentation, but for sure we shall be able to recover the presentation and we shall upload it on the website. So we know the dimension, the size of Motor Sich, a company that now we can hear you again. Yeah. Hello. No, it's happening something with the settings. Okay, so unfortunately we have to stop here. So thank you for the very interesting presentation. We shall have the presentation and we shall upload it on the website of the conference. Thank you very much and congratulations for everything that you are doing. So now we are moving forward and we have a slight change in the program because Professor Dumitrache at present is in a meeting, but we have with us the colleagues from PTC. So I would like to welcome Mr. Bernhard Hebel and Mr. Alexandru Cazacu. They are representing this company that is worldwide known, the parametric technology company, but known as PTC. We, in most of the universities, we are familiar with ProEngineer and Creo and ThinkWorks. And today we shall see the updates coming on behalf of this very important company. So I would like to welcome Mr. Eber. So please, you have the floor.
Hey, Professor Mahmoud, and to the entire audience, thanks a lot for inviting us, for having us here. So my name is Bernhard Eberl. I'm part of PTC's academic team since several years, based out of Munich. And I'm today here with my colleague, Alexandru Casacu, who is our senior application engineer. And we are focusing today on presenting to you our latest offer in the academic space, which is called OnShape. So OnShape is a fully cloud-based CAD technology. And first of all, I would still like to introduce to you a little bit what PTC academic program stands for, and then talk really and give the floor over to Alexandru, who will present it live to you. To the next. So what is PTC's academic program standing for? So our goal is really to motivating students to take STEM education and really provide them with access to technology that is being used in industry. So this is very important to us. We have over 50,000 customers worldwide in the industry space. And of course, they need students with skill of technology that can be used afterwards in industry. So a part of providing access to the software, we are also providing access to many great training resources that help the professors and the students getting started. We go to the next slide. So where are we present with our, of course, working with the normal academic institutions like universities, colleges, but also Ministry of Education. We are working with research organizations like Fraunhofer, you all know them. We are working with the Advanced Manufacturing Research Center in the UK. And last but not least, we have commercial customers who are using specific academic licenses to train their students on site. And we have customers like Bosch, KTM, Liebherr, KMF, and many others who have dedicated Creo, that's a next Pro E, the former Pro E, they have dedicated internship licenses to support their training programs. We are really a very strong global academic program, so are present in over 40 countries worldwide. And you see here some high-level reference customers from the academic community, like Harvard and many others, who also on a daily basis are using our technology to train their students. If we go to the next slide. Where are we present? Which type of offerings do we bring to the academic space? So on the left-hand side, you will see our cloud-based CAD platform OnShape. Creo is our former ProEngineer. So Professor Mahmoud was mentioning this initially. So you have heard of this probably. That's part of our portfolio. But we have also an augmented reality portfolio, which is Fuforia. ThingWorks is for smart connected products, Internet of Things applications, MatCut for engineering calculation and documentation, and Windchill as product lifecycle management solution. So overall, we have over 30 years of product development experience and are working really also with the schools and want to motivate the students from schools also via competitions for STEM. And you will see on the next slide a very nice example of a competition that we are specifically running in the K-12 field, school field. First Robotics is a global, well-known competition hosted normally in the US. And due to COVID, of course, you can imagine where academic institutions were facing the issue that they needed to lock down, being closed everywhere globally. Due to this fact, the normal competitions in a physical event could not happen. And this is why we have been hosting the very first time our own robotic competition based on Shape as development platform. So, and this was called Robots to the Rest. And we had hundreds of students, teams working in teams, collaborating based on cloud-based design form on Shape. Important competition for a student is a where PTC is providing where PTC is providing also full set of technology to the participant. Can you move to the next slide, Alex? Not have issues with. Okay, perfect. So I'm mentioning that we have also resources for professors to get started. So we are referencing the slide.
Yeah, Berhard, we lost you. I don't know exactly why. Maybe the connection.
Right. So I'm sorry for that. It seems that my colleague Bernard has a bad internet connection this morning. I can continue.
Thank you very much, Mr. Kazako. So now you are continuing.
Yeah, I'm continuing the same presentation, and at the end I will also show the OnShape platform. So we have a lot of educational resources. And in here you can see the PTC community activities and the things that we are doing on social media, the Harvard Business Reviews that are really important, and they are a great resource for education, and also a lot of case studies from different universities. As I said, we're also present on social media, so please follow us on Facebook, LinkedIn, Twitter, and Instagram. We also share our partners and our academic partners and users content there. So we also like to promote our partners. So in case you are using one of our products, don't hesitate to share it on social media and also ping our academics so we can also reshare it and repost it. About OnShape, so OnShape is the new SaaS platform. It's a complete SaaS, so there's nothing to install, nothing to. It doesn't actually need a high-end computer. It can run on many devices. And we have two educational offers. The education standard, that's free for anyone, and it will be free for any student. This is individual version, so you can have all your students sign in and yourself as well, and you can manage them, but you can't actually manage them directly. So you will actually need them to share the content with you, and afterwards you will be able to see it. And this is the education enterprise. And the education enterprise is actually the area where where you actually are functioning as an enterprise. So you will be able to add students, to remove students, to organize them in different teams, to share content with specific teams, and manage everything at a very high institutional level. These are a couple of challenges that CAD in education are facing. You pretty much know them, as I think everybody's right now on online, and I won't actually go through all of this, but you already know that the problem is that the students have different types of computers and they don't always have a high-end computer at home. and there are a lot of different devices, and they still need to learn even if online. And Onshape is answering all these issues as it's one a professional CAD tool that has also an integrated data management. So here we no longer speak about files. You no longer have to share a file or an assembly or something like that. It's just about documents that are all hosted online. Um, you can access it anywhere, anytime, and from any device. And this is really important because it's also available from Chromebooks. It's also available from a mobile phone or from an iPad. It doesn't require any installation, any upgrade, any update, or any save. So every time you go online, you work on your projects. You have all your projects, no matter if you're in a classroom, in the school, in a university, in your lab, or if you're at home, or if you're, I don't know, in a train. And another really cool thing is real data collaboration. We call it like the Google Docs of CAD, because multiple people can work on the same document. So in here, it's not like in other software to check in or check out or do anything like that. Everyone can work at the same time on the same part or on the same assembly or actually in the same document. Um, this is just about Onshape Education Enterprise. All the things that I've told before were about Onshape, no matter if you're using Education Standard or Education Enterprise. Now I'm going to speak a little about Enterprise. On Enterprise, each school gets its own private domain. So it will be something like school name.onshape.com. The universities or the schools will have access to data analytics, and this is like a really great tool where you can see how long your students worked on different tasks, if they worked directly on that one, or if they asked a colleague to help them, or if they had someone else helping them with that. You also have the action items that allow you to and your students to assign tasks to you can assign a task to a student, and the student can get back to you when the task is done, and you can check that. There's an SSO integration. You can also bulk add the students. So in here, not every student needs to create his own account. Or you can bulk add your class, and you can also bulk manage your classes, and you can add the students in teaming classes and in any form you would like them to work with, and of course not just students, also the faculty members. You have the global permissions that will actually give different rights to different categories, and this is also a great tool. And also you have the release management workflow that can also help really a lot. Of course, with teaching and also with managing um, the education enterprise. This is John Hashtick, the founder, one of the founders of Onshape. As you may know him from SolidWorks, as he was one of the founders of SolidWorks. And this is his quote: "We desired Onshape to get the technology out of the way of learning." So this is just about the thing that we also tried for more than 20 years now to get to the universities and the schools the same software and the same resources as the companies use. This is about the curriculum and the learning. Onshape has a great learning uh, tool. So I will be showing this in Onshape in a couple of minutes. There are lots of webinars and a lot of content. So even a student that don't actually know anything about CAD and he doesn't have a teacher to instruct him, he can get started with Onshape on its own, just using our resources. The marketing resources are on social media, of course, a lot of case studies, and you can also share your case study with us. And we also have different student competitions. Bernard mentioned earlier the Robot to the Rescue. And this is another one that we had on social media, a design of Jack-o'-lantern design competition. Bernard, are you still on? Is your internet connection better now?
I hope it's, I'm not sure. Can you hear me?
Yeah, I can hear you. So I will let Bernard talk about these couple of slides as he got directly involved into these deals, and I'd like you to get the information from him. So Bernard.
Great. So I just wanted to highlight here some strategic alliances that we were able to build with Onshape. So the Federal Ministry of Education Research in Germany has a so-called MINT-Allianz STEM Alliance, and you see many parts of this STEM Alliance, and PTC Onshape is one of the partners field of Onshape, really growing Onshape as a digital remote and learning academic space. Another great example is on the next slide. So there is a largest school network of STEM-friendly and digital schools in Germany. It's called Zukunft schaffen, MINT-freundliche Schule, supported by the Engineering Association and many global players like Deutsche Telekom. So here, STEM-friendly and digital-friendly schools are receiving awards every year. And PTC Onshape was partnering with this association and has been demonstrating Onshape during the virtual award ceremonies of those STEM-friendly, digital-friendly. And we get lots of feedback about Onshape, even the schools, so school space under university and University of Applied Science. And that is another great example. When the COVID was hitting our country, the German government was organizing a hackathon, which was us, and there were over 28,000 participants, and Onshape, a technical solution enabler for 430 projects. So we got connected to a big maker community on Onshape as a development platform, really great applications based on Onshape. And then last on my end is now lead Europe and lead. We were in contact with a student design challenge in India, and as you can imagine, in when the lockdown was also hitting the country, universities and the students did not have access to expensive hardware, so no MacBooks and things like that. But due to Onshape, they were able to host this design, and there were over 100 student projects submitted and realized in Onshape. And so you see one here on the hand side where they were working on a ventilator, and they really provided a nice related to Onshape to the learning center that Alexander was doing. I wanted to end my part, give the floor to Alexander, who will give a live demo of Onshape. And if you have any question interested in using Onshape, feel free to write me an email. Put my contact details in the chat. Looking forward to working with some of you who might be interested in this during their teaching activity. Thanks a lot.
Thank you very much, Mr. Eber. Very, very important presentation. So, Mr. Kazaku, you will make us a very short
Yeah,
presentation.
please stop me when I need to. Okay, I'm going to go very fast through a couple of stuff that is in the enterprise in Onshape Education Enterprise. You can see here the Google SSO and also the simple sign-in. It's something that works just in a browser. You don't actually need to install anything, and you don't have any local data. So everything is online. You can have an exercise. So this is how a document looks like in Onshape. As I said, we're not speaking here about files. We're speaking about documents. As Onshape is also a data management platform. A document has multiple tabs. It has, for instance, this multi-body. It also has an assembly. And I can also see how this assembly works, if it's been correctly assembled. I can have, of course, a drawing, and I can have also a PDF file or imported parts from other software, and also videos or pictures. And this is really cool because you can prepare a document like this, have a couple of parts maybe for your students or a part of the assembly, have the information in a PDF format, maybe have some pictures with the expected design part that the part that they should design, and the students can do the work within the same document and then assign it back to you. Okay. Let me get back to the most interesting part, and that's the analytics. So in the analytics area, you can see everything. So you can see all the information about the user, for instance. So you can see one of your students that maybe did something that was over expectations. I think that someone is presenting now, right? So I'm no longer present. You no longer can see my screen, right?
Not correct.
Yeah, so I think...
Dumitrache, dacă puteți să opriți share screen. Domnul profesor Dumitrache. Okay. So now you can continue, Alex.
Yeah, so I will just show this very interesting stuff, and after this we'll end my presentation. So I was talking about the analytics, and I'm going to open here just my dashboard from this company, so you can see here that it's an enterprise. Sorry? Okay, so here you can see the total modeling time that I spent on online on Onshape platform. You can see the project that I spent time on and the time that I spent on each assignment, on each project, where I worked from, the location, and also the device that I used.
Nicio problemă. Da, vorbim.
Okay, so also on the analytics area, I can see the analytics on a document. So for instance, if I had a team that of multiple students that was assigned a project, so I assigned to a team of 5 students a specific project, and I want to check if all of them worked on this project. I can go get on the document list, and just let me identify something that was collaborative. This was the one. So I will just look at the document dashboard, and in here you will be able to see the top contributors. So it will show me who worked on this project and who didn't. So this is really valuable for the task that you assign to a team. as in here, you can see exactly who modified the document last one, and also the top contributors will load. WebEx is usually killing my internet connection, as everybody, and as OnShape is an online tool, the analytics takes some time sometimes. But you can see here that we have three
Mr.
people.
Kazaku, maybe
Yeah.
you can conclude this, because of course the presentation of OnShape could take for many hours.
Yeah, no,
And
this is the thing that I'm going to end with. This was the last thing that I wanted to show you, that I can see here that two students probably cheated. 1% of the project and 0.53% is not actually contributing to the project, and 3 worked on this one. So that's pretty much my presentation, and thank you very much. And again, if you have any questions, don't hesitate to ask, or we'll still be here for some time more, and we'll be able to answer in the chat. Thank you very much.
Thanks a lot also from my side. Thanks a lot.
thank you very much, Mr. Eber. Thank you very much, Mr. Kazaku. In 2014, I had the chance to be in Phoenix, Arizona, at the conference for digitalization in industry and the COFES. And it was the first introduction of OnShape. And at that moment, I knew that this is the future. So I congratulate PTC for this partnership with OnShape. And now today it's a different new standard. Thank you very much for your presentation. Now I would like to invite academician Ioan Dumitrache. So Professor Dumitrache, he is a very well-known scientist on computer sciences in Romania. Actually, he built up a school at Polytechnica University of Bucharest, and today he is continuing his activity at the Romanian Academy. So, Professor Dumitrache, please, you can start your presentation. Thank you very much.
Thank you very much for your presentation. Good afternoon for everybody. Today I have to make a short presentation, an overview about the future of factory in the context of industrial revolution. I have to make an overview about some aspect about next generation of the factory based on the new technology. My presentation have to include driver and challenges, cyber physical systems as a new challenge for the industry, a new concept, intelligent cyber enterprise, and a new paradigm what have we produced, factories of future toward next industrial revolution, and some conclusion. Some drivers and challenges for this new revolution, but it's working now. Some element based on the complexity of processes and infrastructure, new requirement and the strong requirement customized high quality products, high progress of ICT, impact on society and technology evolution, and sure globalization and sustainable development. If you have in mind what means new generation of industry, new generation of business production systems, we have connect all aspects from economy, from society, and from environment. This presentation have to make a connection between knowledge and technology, between smart product and services, and sure have in mind market and investment. If have in mind also increase the efficiency, reduce time to market, and also to increase the flexibility, increasing importance of the industrial IT industry software. We have these three main components we have in mind when we have to grow importance of manufacturing industry in all economies. Another element we have in mind, Internet of Things, Internet of Services, wireless sensor actuator networks, and pervasive systems go to a new industrial revolution. We are going for this new industrial revolution. We have to have in mind new materials, new technologies, new approaches in complex process control techniques. We have to create networks of embedded systems. We're going to a new generation of systems, this new paradigm, cyber physical systems. That means a new generation of complex autonomous systems. If we have in mind evolution of the computing and also how to proceed the data, in 1960 we have only documentation and digital data collection, and we have created first databases. In 1980 we have to create enterprise management and data cubes, relational databases, financial data. In 1990 we have data mining, statistics, artificial intelligence, machine learning, knowledge discovery, unstructured data, and we have to work to process optimization. And now we have worked with big data analytics, and we have in mind stream processing, autonomous systems, collective intelligence, massively distributed analysis, heterogeneous data and knowledge, petabytes of data, and we are working to create real-time decision support and control. We have some requirement for the next type of enterprise in the future. Agility, adaptability, autonomy, and flexibility in production systems to face high dynamic and uncertain environment. High capability for self-configuration, adapting itself to unpredictable conditions by automatically changing its configuration, adding or removing new resources for creating new tasks. Capability for self-optimizing, tuning itself proactively to improve its performance by goal-directed control as a response to environmental changes. What means CPS and what kind of challenges create for the industry this new paradigm? We have in mind that the manufacturing cyber physical systems contribute particularly to addressing customer requirement, optimization of production processes, improvement of the ecological balance sheet. Production system could be better, react in real time, cooperate with ultra flexibility even behind company boundaries, enable rapid production, produce resources efficiently, adjust production to the human workforce. The machine follows the human work cycle. In this structure, this scheme, we have make a connection between what means cyber systems, what means cyber physical systems, and what means physical systems. All of them are connected. We have in mind different types of algorithms, architecture, virtualization, dependability. We have in mind embedded controller, Sigur created different platform and different tools. Production systems have in mind automation, control flexibility, adaptability, security, business integration, and sure product systems. In this structure, we have also a good connection between what means cyber physical process systems with different semantics, PLM, CCM, CRM, quality management systems, ERP, smart factory application platform. We have in mind use some smart material, some application platform to create smart production. That is a connection how different elements could be integrated. We have to integrate Internet of Services, Internet of Things to create a new generation of factory. In these schemes, we have to look how are organized in this moment a new industry, new process technology. In the first level, we have Internet of Things, smart items, execution, edge processing is the first level. Second level, Internet of Services, how to create service delivery framework, business process platform, service-oriented architecture. Internet of Business Processes is a third level. We have to develop some business application, process automation, end-to-end process integration. And finally, in the last level is the Internet of Brains, where connected people, insight, and decision. If we have in mind how cyber physical systems is integrated in manufacturing and show in the general enterprise, we have three components: technology development, process and system management, enterprise management. With all elements, we are going to connect all these elements: new product, alternative tracks and materials, new pathway and processes, and so on. Workforce acquisition and knowledge management, water management, environmental quality, life cycle assessment and design for sustainability. All of them are connected with this element for this new type of enterprise. Cyber physical systems. What means? Are physical, biological, and engineering systems whose operations are monitored, coordinated, controlled, and interpreted by computing, communication, and control. It's a National Science Foundation National Science Foundation report. That's a definition. But it's a real integration, this component, computing, communication for control. That is a C3 paradigm. It's a new technological revolution. It's more than networking and information technology. It's information and knowledge and action integrated with physical systems. Are integrated computer with the physical world, with the sensing, decision, actuation, computation, networking, and physical process are integrated, tight integrated. Some trends and future research direction in the cyber physical systems application. I have selected life supporting micro devices, system for more efficient vehicle communication, smarter, more connected process for agile and efficient production. Here we have integrated all elements to create new internet-based services in business model. We are going to a smart factory with smart services, smart product, big data systems, and all cycle is closed by using visualization, management, optimization, production, and so on. Here we have selected sub element. We have to create this connection between human and also human with machine. That is new concept, integrated M2M communication, M2 human communication to create a real cooperation between machine and natural agents. Some disruptive paradigm in production based on the future internet. I have selected here some elements that communication M2M and all IP factories, embedded digital product memory, green and urban production based on cyber physical production systems, application software defined product and smart production. Show flow level with different elements. I have to select from different machine to line of production and toward flexible manufacturing systems. The physical location of cells is important rather from the organizational and technological point of view, not from the conceptual. Organizational level and last control architecture that imply different architecture toward agent-oriented structure with different degree of hierarchy, embedded compromise between flexibility and robustness and efficiency and predictability. Resource planning and scheduling, supply chain management, and real-time monitoring evolve in parallel as support for control. Technology and information flow management. We have selected knowledge management as a discipline to solve many of the enterprise challenges, especially to full use of their capability and to proactively act on the back end. From mass production to smart factory, we are going this direction. All problems we have defined, all previous areas are interrelated. Then they generate an emergent behavior of the enterprise. A change in one area impact on all. Local optim does not mean global optimization. Solution to create cognitive factory or smart factory. We have some definition for cognitive factory. We have not to stay more about this one. We believe that this goal may be achieved also by integrating cyber-physical modeling approach, where real human are part of cyber-physical systems. Human in the loop is reality in this case, given high efficiency to communication, context interpretation, knowledge integration with implicit learning capabilities. What means smart factory? That is a sustainable and service-oriented business practice. It's working in a global environment with different physical location. Each with these particular competencies and functionalities, cost and availability. A network of flexible production systems. Planning of production and production capacities extension should take into account a situation-based global planning for local production development. Each subsystem of the enterprise should have both the capacity of independent action and the planning defined specification and the capacity of communication, allowing the transfer of metadata, information, and knowledge between components in order to offer reliable, context-oriented behavior. That is a general scheme, what means smart factory, with different components. We have some global facility with the planning, local production, situation-based extension of capacities, usage of synergies. Virtual production, smart product, social machine, augmented operator. That is all component to create a new challenge for the next industry. Smart factory, optimization of production line processes. Virtual factory, managerial controls through cloud, flexible, high flexibility to react to market, so intelligent orchestration of the production system, including product property, cost, logistics, security, time to marketing sustainability. Full integration of the value chain through internet-based business process. Digital factory, first time right made in Europe. It is responsible for high variances, short and emergency cycle. Smart factory, factory from computers. Virtual factory, managerial controls through the cloud. IoT, Internet of Things for fully integrated production, supply chain, logistic and customization needs in real time, from supply chains to business ecosystems. There's some common point of these three components I've defined. Enterprise is a network of autonomous entities with different elements, human and individual agents, physical structure, functionality, and local purposes, but which should generate, by their interconnection, an intelligent emergent behavior with a common goal. Enterprise is a complex, high dynamic system facing an unpredictable environment to which it should adapt by reactive and proactive behavior. The link between the enterprise entity is information flow. Any modern enterprise should have an integrative information system. Knowledge is one of the most important assets of one enterprise. Human may be considered as intelligent agents that are acting in close interconnection with other resources, given them superior goal and capabilities. Approach manufacturing facility are connected, horizontality and vertical. Specific goal for cyber physical implementation. Reference architecture for their integration of company through supply chain and value network. Complex system modeling and control. Work organization and design. Education, training and life learning. Optimization of resource efficiency, security and safety. Ensure communication network and knowledge management. They have a evolution of the different stage of evolution of industry. The first industrial revolution, second and third revolution. And here I have selected special for next industrial revolution based on cyber physical production systems. We have different type of element integrated based on what I have discussed before. Here I have connected different element. What means industry 4.0 with connection is grid production and urban production. What means smart factory in the city, close employees' homes. Intelligent cyber enterprise.
So, Professor Dumitrache, excuse me, but we shall have quite a limited time. Can you?
Thank you. A few minutes, 2 minutes, I finish.
Yes, thank you very much. Thank you.
I have to introduce new paradigm, intelligent cyber enterprise. That I work in this integration of cognitive object, using cognitive agent, imagine the virtual and physical world. I have to create, and this scheme show us how was evolution of enterprise, and they are going now in this direction to create this intelligent cyber enterprise. We have to connect virtual organization, biological manufacturing, cognitive enterprise, ensure smart manufacturing, what I have discussed before. That is a connection, how was evolution from technological point of view and from organizational paradigm. That is a new concept that we have in mind when we have to create future enterprise based on the cyber physical system. Thank you very much. I close here because I have some conclusion, but it's okay. The time is ready. Thank you very much for your attention.
Thank you, Professor Dmitraki. It is a pleasure to follow you. I'm sure that even if we shall continue this over the entire day, you will have so many things to teach us, and we have so many things to learn from you. But I hope that you will also continue to participate today. Maybe you have some time, and during the discussions, you could also present your ideas. Once again, thank you very much for this brilliant presentation. Now, I was a little bit, let's say, tight with the timing because we have invited Professor Horst Orsolitz from Vienna. And Professor Orsolitz, he has some courses after this presentation. So for this reason, he has some constraints on that. So now I think from 10 o'clock in the morning, our time, we worked just to prepare the introduction to your presentation, Horst.
Okay.
Because up to now they were presented, let's say, the context, a very important factory, which is Motor Sich with 20,000 employees, a huge industrial platform in Ukraine. We had some presentations of outstanding tools from PTC and very nice concepts that have been introduced by Professor Dumitrache. So now you have to bring from one side the virtual engineering and from the other side digital factory, and to show us the unbelievable, beautiful things that you are doing in Vienna at the Technicum University of Applied Sciences. Thank you, Horst, for participation.
Thank you very much for your honor.
So first of all, Professor Dumitraki, you have to stop sharing.
Yeah. Yes, yes.
Yeah.
Thank you very much, Professor Mahmoud, for the nice introduction words. It's a pleasure for me to participate. Hello from Vienna to everybody. I'm very happy and I'm very pleased to show a little bit of what we do, combining our digital factory with PTT technology mainly. So just let me start sharing the screen. And now you should be all able to see my screen and hear me. Hopefully loud enough to everybody. So we're here in Vienna. Probably I turn off the background because my computer says to. We are here located in Vienna at the University of Applied Sciences. My name is Horst Orsolitz. I have a background in mechatronics and robotics and have been in industry for several years in product development and manufacturing systems. And since 3 years, I'm head of the competence center called Virtual Technologies and Sensor Systems here at the University of Applied Sciences. And my research topics are digital twins and virtual technologies in industrial environments, always connected to education, not just solving problems in industry, but also how to use this technology to optimize our teaching and education system. So just 1 minute on who we are. We are based in the center of Europe in Vienna. We have roughly 4,500 students right now, mostly online as everybody in Europe. And we are a member of the European University Association since 2012. We are called University of Applied Sciences in a comparison to the technical universities. We have a strong focus on lab education, on practical education, and mostly industry-related research topics. So what we do in my competence field, I'm allowed to lead. Our mission statement is we try to come from virtual to industry solutions. So using Industry 4.0 technology, what was the outcome of the last revolution, as we saw in the presentation before. We try to open up or identify business potentials or usage potentials of these technologies, always linked to industry, manufacturing, and with a strong focus on robotics. Having the main topics as industrial digital twins, everything related to mixed reality combined with industrial IoT solutions to offer a strong technology frontline for new challenges, for new ways of problem solving, and for new ways of engineering, in my point of view. So what you see here is we have a small desktop robot developed in our house and his digital twin right next to him, showing the current motor data. In this point, it's the current the motors are consuming, and we are able to highlight each axis and see how each axis performs depending on the torque applied on each axis. For instance, what we do in our digital factory is our main field of research lab. We employ around 16 industrial robots integrated within a production facility. We're producing down in our lab. And these are the main topics we are dealing with. I invite you to attend this video. I hope the speed is good enough. So we use this as a research lab for our students and industry partners by combining all the mentioned technologies like 3D printing, freeform 3D printing, mobile robots, industrial robots, AR and VR, into one facility to be able to identify potentials along the whole value chain in a manufacturing environment, say it that way. We are not focusing on being the fastest and most effective production facility. We are dealing with, or we are operating with mobile robots. So we have a flexible production system, also a flexible manufacturing system where each participant is interconnected, machine-to-machine communication is a strong background necessary there. And, And the communication between all those participants is breaking down the classical automation pyramids as most manufacturing facilities are using or are equipped with. So we are using an agent system where, and connecting to the previous presentation, where the human factor is also represented as an agent who is integrated in this manufacturing process consisting of robotic agents. We use virtual reality for visual commissioning, for instance, and also to optimize production processes so far. Augmented reality in this scenario is mostly used for optimizing human-machine interfaces. So how can students, or in fact industry workers, better understand what a robot does, what a robot is going to do, and how to intercommunicate with the robot. Here are some samples for which applications we are using augmented reality. This is a HoloLens application for a maintenance case where you've got a description on how to change these gripper fingers, which tool is necessary. The big advantage of the HoloLens is, of course, I've got hands-free operation, so I get all the necessary information in my side of view, and I can operate with the hardware with both hands. So the second video shows an early stage of the digital factory in virtual reality. So we have the whole infrastructure also in virtual reality environment to be able to simulate different process operations, different navigation pathways for our mobile robots, different methods of how to program robots, interacting with robots, without being exposed to a real industrial robot. So for training, it's possible to interact with a robot without any safety regulations, without any safety issues, which is very good for the first semesters, for the bachelor students, to get a first feeling on how a robot operates without being harmed. And the last video shows an application within this factory for the packaging station, where the collaboration of a universal robot using the HoloLens and a human worker is articulated, where the universal robot positioning this package material, cartony, in the right height, depending on the worker who logged into the system. So we have a height invariant application, and the folding needs to be done by hand because this is quite a challenging task to automate. So this is still done by hand, and we're using augmented reality to optimize the process on how this carton has to be folded, or this package has to be folded. And again, keeping in mind that we are emphasizing flexible manufacturing system with, let's say, lot size 1 is 1 goal. So we have a lot of different packaging sizes and packaging formats where we investigate on how much benefit such an application would introduce to manufacturing process. We're also using augmented reality for education, especially for robotics fundamentals, so that our students got the opportunity to better, or we try to help our students to better understand how an industrial robot is built, how its kinematic chain does interact, what degrees of freedom mean, and how coordinate systems or coordinate transformations are done. So this is an application we roll out to all our first level students, so that they are able to explore the, let me say, the miracle of industrial robots at their home space, wherever they are right now. And also it's possible to interact with this model. And we see this as a possibility to, especially in times with these, to get our students deal with this topic, get some knowledge or a fundamental knowledge of this topic, and to be able to have it in their hands, let's say. And a second application, again, with the HoloLens, where we have first combination of IoT and augmented reality. So we're gathering live data from this controller, from the robot controller, and we're superimposing the current angle information on each axis of the robot. So we try to make our students understand the complexity of a robot controller, that it permanently has to calculate all these values in order to achieve the programmed path for the end effector, for the gripper. So the inverse kinematics understanding is crucial for robotics or for a well-designed robot application. And with this application, we try to help our students understand the complexity of the 6 axes and the sum of all 6 axes resulting in a movement of the end effector. And to help understand the complexity is the main goal here. And to be able to understand digital twin technology, we have formed this demonstrator where we connect hardware, in this case it's a small desktop robot, with software, augmented reality app, where we are able to control the robot remotely from, I would say, anywhere we are, as long as we are connected, and also to get direct feedback from the robot to be able to show his digital twin. And we use this demonstrator to first explain what we understand under the term digital twin. It's a wide term, everybody explains it differently. For our understanding and our meaning, once you have a connection between a virtual model and a real model in both directions, you can speak of a digital twin, or we speak of a digital twin. With all these possibilities coming up here. So again, we see all the angle information here, the current data I've shown before, temperature of the axis, downtime, whatever information you can get from the controller, we are able to superimpose on the digital model. And finally, application we realized a year ago with the idea to fulfill these challenges, to have a simulation in hands of a digital factory, which is cost-effective and interactive, which allows us the possibility to show a remote support showcase, and also to showcase, to help find CEO decisions for an augmented reality model of our digital factory. Why do I mention CXO or CEO decisions? In my experience, it's kind of hard when you're in a meeting with CXO levels to explain a new setup, a new technology, a new design of your product. You always need to have a CAD guy with you, showing all necessary angles and views within your CAD model. Augmented reality, by the usage of a tablet or a mobile phone, decreases these technical challenges, because everybody knows how to operate it and how to handle it. And this is inspired by the work of Mr. Porter and Mr. Heppelman in their Harvard Business Review article a couple of years ago. We came up with a one-pager showing one part of our production, of our digital manufacturing system of factory, where we use mobile robots, different stations, shown here, with end effector changing systems. So 2 of these robots are capable of drilling holes, for instance. And we can use this one-pager and the augmented reality to explain a smart manufacturing concept we are following. So each of these stations can request the mobile robot and vice versa. So if the mobile robot recognizes his next production step is to have holes drilled in this aluminum solid, he asked all his colleagues, hey guys, I need 4 hosts who can do me this favor. And both of these stations here could reply, I can do the job in 2 minutes. The other station might reply, I can do this job in 5 minutes, but I have the higher accuracy than my colleague. And the next best step is decided by the mobile robot, depending on his actual position, pathways to these 2 robot stations. So this is a completely new way of manufacturing planning processes. And we are heavily investigating such challenges within our digital factory. I hope I'm within the time limit and that everybody of you could follow the videos, and the internet connection it was stable enough. It's always a challenge when the whole world is online to do video presentations, but I hope you could get some insights and some ideas of how to use these technologies, augmented and virtual reality, within the setup of a smart manufacturing environment. And I'm happy about any questions if we have the time for that.
Thank you very much, Horst. A very nice presentation, because of course it is also extremely important to have some very clear principles, concepts, and let's say referential for understanding the digitalization. But here, what you are doing and your team in Vienna is to build up this with, let's say, robots with different intelligent devices, and to put them in the use of students. And this is extremely important. So we had to have a coffee break now, but instead of the coffee that you can have it next to you, I would kindly ask the audience if there is any question to Mr. Orsolitz and about, let's say, their experience in Vienna. So, any question? I have, for starting a question, Horst. So, in principle, in building up this facility that you have in your university, have you started with some, let's say, job required skills that you have to build, or you have started from developing different concepts and then try to use it for training? So what is the relation between, let's say, building skills and training, and on the other side, the concept proofing?
Do you mean by, for the development of the digital factory or the application?
Yes.
Okay. Yes. So, short travel to history. The study course Mechatronics Robotics here at the university started 12 years ago. And during these years, the study course, how should I say that, collected or introduced more and more industrial robots into the lab. But all of these have been single stations dealing with single tasks in robotics. 3 years ago, no, 4 years ago, it's 2020 already, 4 years ago, some of my colleagues decided to form all these robots into one manufacturing infrastructure and build up a production system. So and we already had 5 or 6 employees who were capable of all the skills for rearranging, programming, and also designing such an infrastructure. So it was more out of the strong background of robotics into a manufacturing system. What was new and what was quite challenging, and still is quite challenging, to be honest, was the decision to use mobile robots. So the first draft have been with conveyor belts between all the stations, huge transport systems and conveyor belts. And by the switch of smart manufacturing or digital factory, whatever you call it, mobile robots have been introduced. And this is still one of the biggest goals or challenges to the precision, control, communication is quite okay still. But these are the challenges there.
Thank you. Thank you very much. Once again, congratulations for what you are doing there. And
Thank you.
Also for us, for the Eastern Europe, for the countries from the Black Sea region, the fact that so close to us, to Vienna, there is such a center of excellence, and we hope we can visit it. And
I hope so too.
And maybe to initiate some partnerships, it is really an important aspect. Once again, thank you for your time, for the presentation, and for all your kindness. Thank you very much.
You are welcome. Mulțumesc frumos.
Thank you. Mulțumim. So to continue in Romanian, we shall move to the Polytechnica University of Bucharest, and we shall invite Professor Alin Moldoveanu. He is the Vice Dean of the Faculty of Automatics and Computer Sciences. And Professor Moldoveanu also has been involved in a very important European project. And from that perspective, we have invited him to introduce this. I hope in, let's say, a limited time, because I'm sure the project is very large and you can tell us many things. But please try to concentrate this presentation. So, Professor Moldoveanu, you have the floor.
I was trying to unmute. Thank you. Yeah, it's first time I'm using WebEx. So hello, everybody. It's very nice to meet you. I'm pleased to meet Professor Dumitrache, first time online, and Professor Eden Mahmoud, it's the first time also. And nice to meet all the audience, the large audience here. It's my pleasure to talk to you about one of our most exciting research projects. Please let me know if you see my screen right now. I shared.
Yes, we can see it very well. Thank you.
I will speak very fast because there are things that I want to deliver, and I will go fast over some points. But if you have questions or if you want the full presentation, just let me know later. The Sound of Vision was a European research project that took place between 2015 and 2017. The problem that it aimed to solve, it's about the visually impaired person, people that don't see well or don't see at all. Actually, it's a lot of them in the world, as you see here, over 30 million only in Europe, more than the population of Romania, for instance. And the visual impairment, it's a very serious impairment. Basically, the limited ability or no ability to perceive what's around you and to move may lead for most of them to sedentary life, social exclusion, economic issues, and overall it has a huge socioeconomic impact. And we are in 2020, and when we started the project in 2014, the main solution was still the white cane. So, I don't know, an ancient solution to say so. The white cane has many issues, and besides the white cane, some of them have access to a guide dog, but as you see, a guide dog is surprisingly expensive. So less than 1% of the visually impaired actually may use a guide dog. It's basically like it's not a scalable solution for everybody. The white cane, its main issue is the short reach, and it has like 1 meter or so. And basically you can't perceive farther than that. Any distant holes or obstacles on the ground or objects to get an idea about the larger surroundings, or head height obstacles, which are very dangerous, one can't feel with the white cane. But still, the white cane, it's an essential tool for them, and we learned many lessons from it. It's cheap, anybody can get it, it's easy to use since moment one, but it becomes efficient through intensive training. It's customizable, so there are many types of white canes, and in time it becomes a sensory extension of the body. The issue is it only detects what it touches, it has a very short range, it requires constant attention. It's like they are moving the white cane left and right, and they are very focused on that, and it occupies one hand. So basically, the sound of vision solution is in principle very, very simple. It emerged within our 3D VR augmented reality group at Polytechnica. The solution is surprisingly simple in principle and surprisingly difficult to make it work. Basically, we need an equipment a wearable equipment to constantly scan and understand the environment, of course, through some real-time 3D computer vision. And then once we understand the environment, we want to let the visually impaired person hear it and feel it through some naturalistic sensory substitution based on 3D audio on headphones and haptics on a haptic belt worn on the belly, on the abdomen. Basically, we want the visually impaired person wearing the solution to hear sounds coming from the surrounding objects and to feel vibrations in their directions. It's very important this representation is naturalistic, and we found out, it was one of our first principles, but we found out that through intensive training it becomes extremely efficient. A brief history of our grant applications: we failed 2 times, first at national level, then there was some Norwegian funding. We were very close each time, and in the end we won the big jackpot. It was one of the first Horizon 2020 projects ever. It has 9 European partners. Professor Unterson from Iceland was the administrative coordinator. Myself, I was the technical coordinator. There were 3 partners from Romania. That's pretty impressive. 2 academic partners and the company. And there were also 45 visually impaired persons involved from Romania, Poland, Iceland, Hungary. Okay. The project has so many challenges, like first some general design challenges, how to extract the most relevant information for the visually impaired, because there's so much information around us, but we can't convey through audio and haptics, which are lower bandwidth channels, we can't convey that much, and we don't want to overload them with information. It's very important to extract and deliver only the essentials. Then it was a challenge how to render the information through audio and haptic in a natural way that it's easy to understand, it's continuous, like our senses, they are continuous. We don't want just beeps, 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 which are discrete. And it should be a way that it's felt easy, non-obtrusive, comfortable in the long run. Then there were so many technical issues. The project was not only a research project, I'd say it was rather an engineering project with so many engineering things to solve. Related to computer vision, to ergonomy, to energy efficiency, to ultra-high reliability. It was important to know to make compromises. This was one of the lessons.
Hello.
I'm sorry, there is some sound coming. No, it's not from me. I don't.
No.
There were many operational challenges, like testing with visually impaired person. It's not the same as testing with.
Doar o chestiune de prezentare și atât. Așa trebuie să înțelegi.
Sorry. There is some sound coming.
Eu îți mulțumesc.
Thank you. Okay. Okay, I'll go. This is how we did the project. This is the project plan for the sound of vision system. Basically, you see we had 5 work packages. 2 of them, the first one was like an initiation to make quick system requirements and architecture. The second one, 9 months, was to experiment with all the technical and alternatives and decide on the best one. And then we went fully agile. We had sprints. Each 3 weeks was a sprint, and we had an improved prototype each sprint. We also had 3 milestone prototypes. An initial one, which was like a proof of concept with just the core functionality, an advanced one or a complete one with all the functionality, and the final one which was after extensive testing. We had this red moment at the middle of the project when we met the European Commission evaluators, and they were very harsh on us. They were basically concerned that we were not able to build the prototype because we were aiming in so many directions and in so many functions. And they gave us useful advice. They told us, guys, focus on the essential, build your prototype, then if there is time, you improve it, and so on. Don't try to build a rocket. First, build something simpler. And it was very good advice. In the end, when we met again with the evaluators, they were amazed by our work. They actually recommended our project for some contest. I'll come back to that later. There are many administrative and financial and legislative issues like the payments of researchers from Eastern Europe. You might be familiar with these aspects in earlier Horizon projects. Like Romania, Poland, Hungary were affected by these issues. Romania, we decided to have like a more brave approach. The Hungarian and the Poland, they were conservative and they didn't want to risk. So their involvement was very small and this affected the project overall. Then the typical issue for the research projects, partners have different degrees of involvement. Some are very interested, some less interested. In this case, we had many opposing points of view because we were building something brand new and people had different ideas how to make it. So it was important to know to compromise and to know to make decisions. Okay. In the end, we reach a system which is a complete package for physical movement. For visually impaired people, it's standalone. It helps them feel and navigate very well, pretty safe. The schematic of the system, it's like this. It's just a scheme, sorry. He's wearing on his head some 3D cameras that scan the environment. The raw 3D data goes to a processing unit. It can be carried in the backpack, or in the near future it will be as smartphones because they are becoming so strong. This one breaks the raw data into individual objects, selects the most relevant ones, and translates the information into audio and haptic vibrations. These are some pictures with the prototype. This is the vibrating belt, an early prototype, a headset, lab prototype. It's important to point out that we reached TRL 7, which probably you know it's super high for a research project. Most of the research projects of this type, research innovation action, they go like 3, 4, 5 TRL. 7 is pretty high because you must have a prototype that was lab tested and was tested in realistic conditions with end users. This is basically TRL 7. Actually, we were somewhere between TRL 7 and 8. This is not just our label, it's the label put by the European Commission evaluators. Okay, basically the future versions of sound vision could be like this, like a helmet with cameras integrated on, maybe in some more years, just some smart glasses. I will skip details, technical details, because we have no time. But basically this is how the systems see the environment. Here we have a very simple test scene. With green, we have the walls, with red, we have the floor, and then the individual objects are shown with blue. And basically, this gets converted in audio and haptic signals for the user. We had many ways of converting in audio and haptics, and the user is able to select the one that he likes more. We tried first to impose a single unified way of presenting information. It didn't work because we found out the visually impaired person are quite different. They have preferences. So rather than force, we decided to give them options. We did a lot of testing, as I said, with 45 of them. This helped us improve our system and eventually reach something that was favored by them and which was TRL 7. For training, as I mentioned, we had 2 stages. First of all, intensive training in virtual environments, and here are some screenshots for plenty of virtual environments that we used. Here is one of our faculty, down right, for example. The principle was when a visually impaired person came to us to test, first of all, he had to go through like 1 or 2 weeks of training in virtual environments and then training into real world. Virtual environments proved to be very safe, very cheap, very effective. So I recommend them as a training modality for most projects. I have some presentation videos. They are linked here. Because of time, I will not go into them.
Professor Moldovan, would you be so kind to pass to conclusions, because we don't have time?
Yeah, of course. Yeah, sure.
Very brief.
In a feature comparison, the sound of vision is much better than the Widescreen and the other ICT tools. What's next? We are preparing continuation projects. We already have a small continuation project and preparing the transition to market. We made the market and business plan. It shows that it becomes profitable in like 2 years after completion. We are looking for partners, for investors, partners with expertise in this area, like hardware manufacturing, miniaturization, product design, and so on. I would like to conclude by saying that our project received in 2018 the Texo for Society Award. It's the prestigious award by the European Commission. Basically, it's among all the European projects that concluded in that year. They said that ours has had the best impact for society. So we were very happy about that. And pretty important, I tried to write down some lessons learned from this project. First of all, about the concept. The concept should be of high impact. It should really impact the life of people. It must aim beyond the state of the art, but still appear doable. And if this is the case and you trust your concept, go for it. Don't give up at the first failure. Try until you succeed. Regarding the planning and execution, we found out that 3 years, it's actually short if you are building something complex. So you need a lot of focus and constant work. Don't let any week pass without something concrete coming out from it. You must stay close to your end users for design and test. And I highly recommend going agile. Agile is typically used in industry, but it can very well be adapted to research. And aim to build a relatively simple solution and then improve it. Don't wait until the late of the project to build a solution, build it quickly.
Thank you very much, Professor Moldovan. Because I'm sure that this presentation will be also available. We shall upload it in the website. So once again, congratulations, a very nice project, and we wish you good luck to see the fruits of your efforts in future development. Thank you very much. Bye.
Bye-bye.
So, yes, now we are moving forward into this digitalization phase, and we invite a team from Turkey, from Çanakkale University, Professor Dr. Jumali Yashar, Mr. Zafer Karadai, but the presentation will be done by Ahmed Bugra Yashar. And the name of their presentation is In-Service Training for Technical Services Using Virtual Reality Supported Application. Ahmed, you have the floor.
Right, thank you. Let me just open the... All right. Okay, first I'd like to thank the members of the organizing committee and scientific committee for this great conference, and I would like to thank Legacy University Network and Professor Idem Mahmut for inviting us here. I am also going to thank Professor Horst Orsolits and Professor Alan Moldovan for the great insights on this topic. We are going to talk about in-service training for technical services using VR-supported applications with narrow education technologies. So we live in an age where social media mentors us throughout our daily lives and observes our purchases and experiences in the market. When we're buying something, we prefer a better technical service feature of a certain product before deciding on anything of the similar price range. So if a company fails to provide a good technical service experience, it quickly falls off the market and causes loss of shares and future revenues. Newer products get more and more complex as days go by, and users have to rely more and more on service personnel to fully utilize their purchases to get the most out of it. But this takes its toll on service personnel. Whereas products get more complicated, service personnel has to memorize and learn more and more skills to keep up. So during this presentation, technical services will be considered in the scope of service stations with at least one branch in each geographical location, and their obligations are as follows: conducting initial inspections, work write-up or project specification development, cost estimate preparation, construction supervision associated with activities that do not require an architect or engineer, lead hazard reduction or lead abatement need determination and oversight, lead hazard reduction or abatement carrying costs, temporary relocation coordination, financing costs such as security agreement preparation and recording or filing fees, processing of individual applications for assistance, income eligibility determination and verification, and project-specific environmental clearance process. By law, firms are obliged to open authorized services, but this is a difficult task to accomplish when finding qualified personnel is a hard task. Authorized technical services jobs are no easier, since they are given various obligations to provide quality service to customers. Considering the payment of fees with the service that they have to do, this is a hard contract to maintain. Now, this, of course, leads to poor service jobs and results in expert service people being questioned regularly. Companies often cancel contracts with service firms and quickly replace them with a new one. This starts the whole finding or training qualified employees process all over again. And we find that a big example of this, a notorious example of this, is the automotive industry, where they don't listen to complaints from their customers and give poor service and have to face frequent service firm changes. Nowadays, luxury amenities in a product aren't seen as extra, they are seen as a must. And this results in diversification of the software of electronic circuits, and different features of the applications of the models require constant training from authorized services, since they have to keep up with new models and learn new learning processes. And this is where VR technologies come in handy, as we will see. Now, due to the fact that VR still feels like a reality, learning in VR environment is a much faster and permanent method than other learning methods. They provide deep and strategic learning quickly. Now, VR learners can experience significant possibilities through simulations due to they would need to work in the field for years beforehand. Now, they don't have to do that. So virtual reality learners increase their self-confidence in applying what has been taught. And now, since they already experienced that through the environment, they can be more confident in their practice. And research revealed that VR learners gain 40% more confidence than classroom students and 35% more improvement than e-learners to act on what they learn with VR. So why VR? Another topic is adoption of content increases. So since in the environment, we still feel like we're in that place, we connect with the environment more deeply. We develop an emotion with the field. And we learned that both through our own VR works and multiple BXC experiences, that simulation-based learning in virtual reality gives people the opportunity to feel like they had a meaningful experience. We also find that VR learners are more focused. Trainees who underwent, yes? Okay.
No, you continue, no problem.
Okay, sorry. Trainees who underwent the VR learning programs were more efficient, less distracted, and quicker to regain momentum like after a break, so they could get back to work quickly and better. So with no stalls or no stall times, we find that this is much more efficient in the long run. And VR is also more cost-effective at a larger scale. So in the past, VR was very expensive. It was very complex, and it was difficult to deploy outside of a small group. It was a niche part of the area, and simulations were still lacking the complexity of a work environment, and firms didn't see it necessary to implement into their training programs. Now, however, VR ecosystem costs around $1,000, but that costs covers every trainee who will undergo the training program on that equipment. Through that VR system. So we have a recycling